Today, we are diving into a really brilliant concept, something that's all about designing with the biggest power source we've got, the sun itself.
You know the feeling, right? It feels like you're constantly fighting your own house, cranking up the AC in the summer and then blasting the heat in the winter just to feel, you know, comfortable. It costs a ton, it's not efficient, and really, it's just a bit of a design flaw.
Well, that's the big question behind solar architecture. It's all about creating buildings that are just naturally comfortable simply by being a whole lot smarter about how they deal with sunlight.
Okay, let's get into it. And listen, this isn't just about sticking some solar panels on a roof. Nope. This is a fundamental shift in how we think about the whole relationship between a building and the world around it.
So the first thing to get your head around is that solar architecture kind of splits into two main branches. On one side, you've got passive design. This is the brains over brawn approach. It's all about using the actual structure of the building. And on the other side, you've got active design, which is the high-tech stuff we usually think of, like solar panels and gadgets.
We're going to kick things off with passive design, and that's because it's the foundation for everything. It's the most intelligent, the most elegant, and often the most cost-effective way to make a building feel great. Now, passive design isn't just one single thing. It's really a system of 4 key strategies that all have to work together. We're going to look at how you position a building, what it's actually made of, how you shade it from the sun, and a few other really clever tricks.
First up is orientation, and this might be the most important decision you can make. And guess what? It costs absolutely nothing. So for a place like Delhi, for instance, you'd want the long sides of the building to run from east to west. This means your biggest walls face north and south. And why would you do that? Well, it lets you catch that nice, low, gentle winter sun on the south side for warmth, while shielding you from the absolutely brutal sun that hammers the east and west walls in the summer. It's just simple geometry, but the impact is huge.
Okay, next up is something called thermal mass. The best way to think of this is like your home's own personal thermal battery. Dense materials, think concrete, brick, stone, they soak up heat from the sun all day long, which keeps the inside from getting crazy hot. Then, when it gets cool at night, they slowly release all that stored heat back into the space. It's like a natural thermostat. And here's a brilliant example of thermal mass in action: the Trombe wall. You can think of it as a clever one-way heat door. It's great at letting heat in, but it doesn't really let it back out. Let's take a closer look at how this thing works. So, sunlight streams through the glass and hits that dark, heavy wall, heating it right up. The air that's trapped in that little gap between the glass and the wall gets super hot. It rises, and then boom, it flows into your room through a vent at the top. At the same time, cooler air from the room gets pulled in through a bottom vent. It creates this amazing, natural heating loop. And then at night, that warm wall just acts like a gentle radiator. So cool. All right, time for a quick question. We all know the sun is way up high in the sky during the summer, right? And it's much lower in the winter. So if you've got a window that faces south, what's the absolute best way to block that intense summer sun while still letting all that lovely low winter sun stream right in? The answer is so simple: a horizontal overhang. Yeah, think of a traditional Indian chajja, or maybe a more modern-looking brise soleil. It works just like the brim of a baseball cap. It perfectly shades the window from the high-angle summer sun, but it lets that low-angle winter sun slide right underneath to warm up the house. That's strategic shading at its absolute best. So now that we've covered all the smart, passive solutions, the brains of the operation, let's flip the coin and look at active design. This is where we bring in the tech to build on that strong foundation. This usually comes down to 2 main technologies. First, you've got photovoltaics, or PV panels. I'm sure you've seen them everywhere. They turn sunlight straight into electricity. And second, there are solar thermal collectors. These use the sun's energy to heat water for your showers, your taps. It's a really simple and incredibly effective technology.
Now, to really get this stuff, you gotta know a couple of terms. It's kind of like the architect's secret code. These numbers tell you exactly how a window or a wall is gonna perform.
First up is the solar heat gain coefficient, or SHGC. Just think of this as the sunglass rating for your windows. It's a number that tells you exactly how much heat from the sun is getting through. So in a hot climate, it's a no-brainer. You want a low SHGC to block out all that heat. The second secret code word is U value. This one measures how well something insulates, or how fast it lets heat pass through. You can think of it like the quality rating on a thermal jacket. And for U value, it doesn't matter if you're in a hot or cold place. Lower is always, always better. You want to keep your inside air in and the outside air out.
So, let's pull all this together. After all that, what's the big picture? What's the main idea you should walk away with?
The real philosophy here is this. Solar architecture isn't about just slapping some panels on a badly designed building. No way. It is a passive-first approach. You use smart design, the orientation, the materials, the shading to dramatically reduce how much energy you even need in the first place. And then you use the fancy active tech to meet that much smaller demand. When you do it right, the building itself becomes its own climate control system.
So, the next time you walk into a building, just take a second. Notice which way the windows are facing. Feel the temperature of the air. Ask yourself, is this building working with the sun or is it fighting a losing battle against it? I wonder, will you feel the sun differently now?